All right, I'm back working through some of these quadratic equations. Where we last left off, we were just going through the quadratic formula. So quadratic formula, as you can see listed here, works for any quadratic equation. The first step is it needs to be in standard form, so make sure you've got that set up. If there would be fractions in your equation, I would times through by the LCD and clear your fractions first. Get it in a good form. If I would have had like a 7, 14, and 21, I'd also divide out by 7 on both sides and reduce it. So whatever you can do to kind of clean it up to its best form before you use the formula is advised. All right, here A is the leading coefficient, which is the 1. B is the middle coefficient, -12, and C is the constant. We plug all that into our formula. The negative of B, will change that to a positive 12. B squared means -12 is squared. The negative is going to be squared as well, which is important. -4 times the A value times the C value, all over 2 times the A value. So you can type this in your calculator, but like I said, just make sure you remember there's an parenthesis around the negative sign, or that will mess you up. You need to get this squared as well. So -4 times 1 times 29 gives us 28. So it's 12 plus this, positive 28 over 2. The next step is just the radical if possible. 28 will divide by 4 times 7, and your goal here is you want something on the purpose 4 minus 16, 64, something that's perfect so you can reduce it a little bit. So the square root of 4 is perfect. It reduces out to a 2. So now we have 12 plus and minus 2 radical 7 over 2. Last step is that if there's a common factor for all three of these terms, not including the radical because that's all one term, so you just affect what's in front of it, its coefficient. So this, and this all divide by 2. So 2 into 2, 2 into 12, and 2 into that 2. Leaves me 6 plus and minus 1 radical 7, or just radical 7 over 1. So just that. That would be my 2 answers. 2, and they're irrational if you're asked what type of solutions. Okay. Number 15, quadratic formula. Let's write that again. Hopefully that's kind of burning into your memory. Just a handy formula to use as you go. If you do enough of these, you do just kind of get that straight. You may have done these over the years already and have that burned into your long-term memory currently. That'd make me happy if you send me an email and say, hey, that is burned into my memory. Some schools have little songs they sing. You can find all kinds of stuff on YouTube videos. If you haven't used YouTube for math, there's really a lot of math on YouTube, so no, that's a resource. Anyway, standard form first, get it all on one side equal to 0. Then A is the leading coefficient, B is the middle term, and C is the constant. We plug that in our formula. Once again, my B is negative. I promise you it's not always negative, but so far examples have been. So it says to take the negative of B, which will make that a positive 4. It just makes it the opposite sign. Then B squared, which will be -4 squared, minus 4 times A times the C value, all over 2 times the A value. Then this is when I use my calculator and type this in. Make sure you use a parenthesis. The -4 is squared, minus 4 times 1 times 13, and that is -36. So I'm going to have an imaginary, right? When you get a negative under your radical. So we're going to have imaginary. The negative is the I, and then 36 is perfect. It comes out to be 6. So we've got 4 plus and minus 6I over 2. And then these three places will all reduce by a 2. So 2 into 2, 2 into 6, and 2 into 4. Leaving us 2 plus and minus 3I for our two solutions, right? X equals, I should say. 2 imaginary complex conjugate, they would be complex conjugates as well. Okay, which will lead into something later. We're going to see a connection when we're looking for zeros. If there is one imaginary binomial, there will be its conjugate as well. So those always come in sets. So the conjugates there. Also notice what determines what type of solution you get is this radical part. So whatever's under the radical, if it's negative, you might notice that if it's negative, you get imaginary solutions. That's called the discriminant of the formula. The discriminant determines. I won't always want to call it a determinant, but that's another mathematical term. But it's the discriminant, and it tells you what type of solutions, whether they're imaginary, irrational, real, or zero. So it tells you how many and what type. All right, last example you'll find is kind of a tough one, I think, because it incorporates factoring perfect cubes. Now, notice this one's out of sorts from this section because it's x to the third. It's not a quadratic in this form now, and we cannot use the quadratic formula on it, but it should have up to 3 solutions. So it's a third degree cubic equations, and cubic equations should have 3 solutions. Well, one solution maybe is sort of obvious if you tinker with your calculator or think about it. 6 cubed is 216. So 6 cubed, 216 minus 216 is 0. So that's one of the solutions. But the other 2 solutions are hard to find by just looking at this equation. And so we have to know this special factoring pattern, which was in your review section. R.4 is all the review of factoring methods. So if you didn't watch that earlier, if you think you need to review factoring, go back to my R.4 videos in your shell and you'll see this pattern. But the pattern for perfect cubes, it's the only pattern we have for cubic factor, is if these are perfect cubes, you can take the cube root of each, which would be x, and the cube root is 216. I said it was 6. 6 times 6 times 6 is 216. So you cube roots, bring down the middle sign, because this will work with a plus or minus of cubes. So you follow where that line is. Then we square this term. We times these 2 terms there. So times x and make it opposite sign. So paired and positive. Now, believe it or not, and I want you to test me on this, if you check this times those 3 terms and this times those 3 terms, this all multiplies back to be that. So for factoring to work, you need to be able to re-multiply it and show it works. So it does, and you feel free to pause the video and check that. But then we would like to factor this quadratic equation. If possible, I would try to do that. I would try to find a combination, x times x. If I did plus 6 and plus 6, I'd get 12 in the middle. That's not right. If I did 4 times 9, I'd get 13 in the middle. Of course, 36 times 1 gives you 37 in the middle, so that's not working. This pattern does not factor any further. So you're stuck there with the factoring method. So we set each factor equal to 0 by the 0 factor method. And here's one of my solutions, the one we kind of talked about that we thought would be there, x is 6. So that is a solution, but there's 2 others. And it comes from this quadratic equation. 2 more solutions for a total of 3. So how do we solve when we can't factor? We use that formula. So just what we were doing, or I guess you could complete the square if you like that. Same difference. They sort of are related, right? We've seen that now. So we plug this in the formula, negative b plus and minus b squared minus 4ac all over 2 times a. And let's see, let's reduce that radical. I've got 36 minus 4 times 1 times 36, and that is negative 108. So definitely going to get an imaginary solution here. So the negative makes the I. And then what about that 108? See, I don't know right off the top of my head either. Maybe you do. But if you do square root of 108, it is not perfect. You get a long decimal, and we don't want that. That's not exact. So we want to try to break it down. Now, I think I remember that 108, well, you could try dividing it by, say, 64. No, that's good. 108 divided by 36 is a good thing, though. 36 times 3 is 308. Break that down. 36 and 3, and you see 36 perfect radical reduces it to a 6. So an I and a radical 3 left in. So let's rewrite it. Negative 6 plus and minus 6i radical 3 over 2. And then all 3 of these parts reduce by 2. We can half each one of these numbers. So go through and do that. And for a final result of negative 3 plus and minus 3i radical 3. So that's a total of 3 solutions, right? There's 2 there because there's plus and minus, and then our 6, 3 solutions because it's a third degree equation. That's really going to be the only third degree equation type that we'll be able to solve by this factoring method. It's the only factoring method that I know of to help us break down cubic equations. Past that, it would be really hard just to try to guess and check 3 parentheses that multiply to be something. And furthermore, not everything is factorable. But this one, we have an algebra trick. We'll call it a tool, an algebra tool or algebra skill we can use. So that's kind of what we're doing in this class, is amassing a set of skill sets. I'm practicing these a lot in Chapter 1, so we'll be able to use them and apply them to other applications later on. So anyway, that's one of our tricks. We can break down that type of cubic equation. All right, if you need me, feel free to send an email. Let me know if you need further videos on any of the things we talk about. Best wishes.